guys, today we're going to do 5-3 solving polynomial equations. So I will be able to solve a polynomial equations by factoring and graphing. To solve a polynomial equation by factoring, we are going to write the equation in the form the polynomial of x is equal to 0 for some polynomial function p, and factor p of x. So we're going to factor the left or right side, the side that is not equal to 0, and use the zero product property to find the roots. This is just like we were doing when we were solving quadratic equations as well. So first, solving polynomial equations using factoring. What are the real or imaginary solutions of each polynomial equation? I'm first going to make my equation equal to 0. So I subtract 3x from both sides. Now I'm going to take out my GCF of x. So I'm left with x times 2x squared minus 5x minus 3 equals 0. I need to factor negative 6. What multiplies to negative 6 and adds to negative 5? Negative 6 and 1. I'm going to divide this one by 2. So our factored form is x times x minus 3 times 2x plus 1 is equal to 0. I now take each factor and set each factor equal to 0. So x is equal to 0, x minus 3 equals 0, and 2x plus 1 equals 0. Giving me my solutions of x is equal to 0, 3, and negative 1/2. For b, we're going to go ahead and do the same thing. Subtract 6x cubed, so 3x to the 4th plus 12x squared minus 6x cubed equals 0. I am going to factor out x squared, 3x squared, because 3 can be divided into each of the coefficients as well. So 3x squared, and I will be left with x squared minus 2x plus 6 is equal to 0. I switched the order of these two terms so that we were in standard form. Now I factor. Can I multiply anything to get to 6 that adds to negative 2? And the answer is no. So this is not factorable. So I'm going to have to use my quadratic equation. So we have 3x squared equals 0 and x squared minus 2x plus 6 equals 0. Divide by 3. X squared is equal to 0. So x is equal to 0 because I square root both sides. Now for my other factor, I need to use the quadratic equation, which we all remember is negative b plus or minus the square root of b squared minus 4ac all over 2a will give us our x values. So 2 plus or minus the square root negative 2 squared minus 4 times 1 times 6 all over 2 times 1. So this is 4 minus 24. So this is the square root of negative 20, which will really be 4 and 5. So we get 2 plus or minus 2i root 5 over 2. My 2's can cancel. So this is equal to 1 plus or minus I root 5. That's two of my imaginary solutions, and x equals 0 is my real solution. These are some factoring techniques. If you don't know any, please review them. Sum or difference of cubes is new. Please familiarize yourself with that. We are going to solve this polynomial equation by factoring. So once again, make our equation equal to 0. X to the fourth minus 3x squared minus 4 equals 0. We have no GCF, so I'm going to factor. Since this is a quadratic-like method, quadratic-like equation, I can use our quadratic methods. So I have negative 4, what multiplies to negative 4 and adds to negative 3. We get negative 4 and 1. So now instead of x, I'm going to put x squared minus 4 times x squared plus 1 equals 0. Because we want our first term to be x to the fourth power. Now I want to take both of those and set them equal to 0 and solve for x. So x squared minus 4 equals 0. Add 4. X squared is equal to 4. Square root both sides. X is equal to positive and negative 2. Then x squared plus 1 is equal to 0. Solve for x. X is equal to the square root of negative 1, which is positive and negative I. So if we look at the graph, of this polynomial equation, we can see our two real zeros. However, the two imaginary zeros do not appear on our real graph. You can also find the real roots by graphing. So if you have a polynomial equation, you can make the two sides of our equal sign y1 and y2. So you would enter them in your calculator under y1 and y2, and you can find the intersection of those two graphs to find your solutions, or you can make it equal to 0 and use the 0 function under second trace, and you could use the 0 function instead of the intersection to find your solutions as well. You guys go ahead and try these, and see you tomorrow.